All right, so there was number 15. Now let's move on to 16 where we need to divide. We have -5 plus 7i. Can you both see this okay?
Yes.
Yes.
All over 2 minus 3i. Now, in order to simplify a fraction with imaginary numbers, we cannot have imaginary numbers in the denominator. So in order to get rid of that imaginary number, what we're going to do is multiply by what is called the conjugate of that denominator, and that will make the imaginary number disappear. And the reason it will do that is we are forcing this to be a difference of squares. And we'll end up with an I squared that we'll be able to replace with a -1. And so it'll turn that denominator into a real number. But in order to keep this fraction having the same value, we have to multiply both the numerator and the denominator by the conjugate, because something divided by itself is just 1. We're multiplying by 1, it won't change the value. It'll just look different. Now, what do I mean by conjugate? If you have 2 minus 3i, you multiply by the same thing, but you change that sign in the middle, 2 plus 3i. And the beauty of doing that is that we'll end up with a difference of squares. So let me show you what I mean by that. If we take the 2 times the 2, that's 2 squared, which is 4. 2 times 3i is plus 6i. -3 times 2 is minus 6i. What do I have there? What just happened?
Canceled it out.
Right, the middle terms are canceling out. And then -3i times positive 3i is minus 9i squared. So when you multiply by the conjugate, you're forcing these middle terms to cancel out. So now we don't have an I in the denominator anymore, because the I squared we're going to replace with a -1. So now in my denominator, I have 4 minus 9 times -1. Well, what's a negative times a negative?
Positive.
Positive. So our new denominator is going to be 4 plus 9. So we just have 13 is our new denominator, and we no longer have an imaginary number in the denominator. So we are well on our way to having a simplified fraction. Now we need to finish up in the numerator. We'll need to take this -5 and distribute it to everything in the other parentheses, and then take the 7i and distribute it to everything. And you are allowed to have an I in the numerator, just not the denominator. It's just mathematical convention. It's very man-made. There must have been a reason of why mathematicians decided to do it that way and consider that to be simplified. I don't know the reason. So I'm sorry, I can't tell you why. All right, the -5 times 2 is -10, because negative times positive is always negative. If you're not real good at your integer rules, just use your calculator. -5 times 3i is minus 15i. And honestly, some of these rules, some of the mathematical conventions go back hundreds of years. And we still follow those conventions today. And again, I don't know if it was something that is like pre-calculator reasoning, or if it really matters to the electrical engineers that actually use imaginary numbers. And then we've got 7i times 2, so that's plus 14. Wait, did I make a mistake there? -5 times 3i would just be -15i. It's not a squared. I don't know where that came from. Gotta watch me. All right, 7i times 2 is giving us our plus 14i. And then 7i times 3i is plus 21i squared. And I hope you're writing this down on your own paper.
I'm taking lots of pictures.
Okay. Okay, and then we can simplify. The negative 15i plus 14i is going to be negative 1i. The 2i squared, no, that was 21i squared, right? 7i times 3i was 21i squared. The I squared we're going to replace with a negative 1. So it's really 21 times negative 1. So it's minus 21 there. Negative 10 minus 21 would be minus 31. And I'm putting that in front of the negative 1i because they, again, want it to be an a plus bi form. So we need to break up this fraction into a plus bi form. So we have negative 31 thirteenths minus I, or 1/13 I. So our A value will be negative 31 over 13, and the B value would be negative 1 over 13. And let's just check and make sure we didn't make a mistake here. And they put in decimals again. .3846 negative. Yes, we got that right. And then 1/13 or negative 1/13 is negative 0.069. Negative 0.076923. Again, if you gave the answer in this format, I would accept you giving the A as negative 31/13 and the B as negative 1/13. Does anybody have questions about that?
I think I misunderstood the the final answer. You're saying the negative 31 minus the negative 31 minus 1i equals the negative 31. I'm not sure. I got lost at the bottom. I'm sorry.
Okay, the 13 here came from when we multiplied 2 minus 3i times its conjugate, 2 plus 3i, and we ended up with a difference of squares. We replaced the negative, the I squared with negative 1, and we ended up with 4 plus 9 was 13. That was the denominator.
Got you. Okay.
Numerator simplified to negative 31 minus I, but then they want it in a plus bi form, so we had to break up this fraction, and so you put each term of the numerator over the denominator. So negative 31/13 minus 1/13 I.
Got you. Okay. I didn't know what that final answer was. Okay. Got it.
Okay. Let's move on. Number 25. We are just multiplying everything out and simplifying. So let's distribute the 10 times negative 12 is negative 120. 10 times 3i would be 30i. Somebody has a fur baby. Negative,
Oh, I'm sorry.
that's fine. No, you don't need to apologize. Negative 6i times negative 12 is going to be plus 72i. And negative 6i times 3i, negative times positive is negative. So we have minus 18i squared. Now we can combine like terms. 30i plus 72i is going to give us 102i. But there's one last thing we need to do to simplify. What is it?
Get rid of the I square.
Replace the I squared with -1. Good. So it's really negative 18 times -1, which is positive 18, that we add to the negative 120. So we have negative 102. Plus 102i. Okay, do you have any questions for me on that one?
No, this is actually kind of clicking now. This is helping a lot.
A lot of it is just remembering how to work with binomials and variables and so forth. And then you just have to remember that added piece to replace your I squared with -1.
Say, I did all this in high school, but my brain injury definitely affected my math skills. So it's kind of like clawing through a concrete wall in my head to get it back again.
Okay, all right. I will recommend that one thing that can help with brain injury and repair is to play classical music while you're studying the math, and that can help just bring about brain growth to grow around the injury and heal and help you remember the math.
Is there any specific kind? Because I've been looking at like alpha wave music and I think it's binomial wave. I'm
That
stuck on math right
that
now,
I
but
don't know. The book I read was called Create a Better Brain by Debbie Pearl. And I think it just said classical music. It's not a real scientific book. It's more for a like a parent or somebody that is not necessarily a scientist, and the book just said classical music.
okay.
It's a parenting book, but it has a specific section related to brain injury, concussion, maybe it talked about stroke, and then a whole lot of helping your children grow their brains.
I will definitely check it out.
So don't know if either of you care about that.
I do.
I still have kids at
I
home.
actually listen to classical often. Not for those reasons, but I just enjoy it.
Yeah, me too. And when I'm teaching at night, I the students can't hear me. So I often will play the classical myself, help myself stay alert, and I just enjoy it too. Okay, I think we've covered all of our imaginary number problems. So Anita, we're back to you.
Oh, I'm good for the moment. I'll probably do another session probably later in the week, but I'm good for now.